Hello, I'm Ashish Kasturi explaining about the DES algorithm. The first step in the algorithm is converting the hexadecimal key into the binary key. The hexadecimal key which we get in the form of 133 457799 B F D1 will be converted into the binary key of zeros and ones. This is a 64-bit key. So after converting the 64-bit key, we use the PC table to convert the 64-bit key into a 56-bit key. Using the PC table, once we get the 56-bit key, binary key, we will divide the key into two halves, the left half and the right half. The left half is known as the C0 and the right half is the D0. Each of these are 28 bits. After we get the C0, we have to do the shifting process. The shifting, there are the 16 types of 16 rounds of shifting, which has each value of 1 or 2 to shift once or twice. So this is a fixed shifting table in the DES algorithm. So once we shift, so for the first step is to shift the C0, which is a 28 bit. If we once the C0 is shifted, the bits in the C0 are shifted, we'll get with C1, which is also 28 bit. Similarly, we have to shift the D0. The D0 after rotating once will give us the D1, which is also 28 bit. Now this process is now once up, the C1 is also again rotated and we'll get the C2. Similarly, the D1 is rotated, shifted, and then we'll get the D2. This process is continued for 16 times, and simultaneously we'll get C1, C2, C1, D1, C2, D2, like that. So far for the C16 and D16. Once we get the C1, D1, we have to send this, using the PC2 table. We have to transposition of the bits again using the PC2 table. Once we have done the C1, D1 with the PC2 table, we'll be coming out with K1, which is the key one, that is the sub key. Similarly, all the C's and D's are sent to the PC2 table. Using the PC2 table, we'll get a 16 sub keys, K1, K2, K3, like that up to 16 keys. The next process is converting the message. The 64-bit message, actual message, the plain text message which we got is permuted. The initial permutation takes place here. The initial permutation rearranges the message, the binary message, and we'll get the left half. Divide this binary message after initial permutation into left half and the right half. The left half is called as L0 and the right half is the R0. Now the L1 which we get after this stuff is directly the R0. So the R0 which we have now becomes the left part of the next coming message, which is the first step in the encryption message. And then the R0 which we have is sent through the expansion permutation. The expansion permutation, and the right half is sent to the expansion permutation. As the right RO is the 32-bit permutation, and the expansion permutation converts the 32-bit RO into the 48-bit. After this, the keys which I've got in the previous step is XORed and sent to the X box. In the X box, the 48 bits are divided into 6 bits each, and sent to the S boxes. The X boxes will have a permutation and XOR the left half of the 32-bit which we got of the initial permutation. So after getting the XOR, after we got the XOR of the initial permutation with the left half of the initial permutation, we'll get the R1. So the R1 is now derived and L1 is the one which is R0. This is continued for 16 times, and then we'll be left with L16 and R16, which is the encrypted message. Thank you.